Let's review solving trig equations, all right? So let's see what we have. Tangent squared of x minus root 3 tangent of x equals 0. And I'll also notice that they're wanting the answers in terms of degrees, but we'll get to that, at the end of the problem. So when it's solving a trig equation, a couple of things we have to keep an eye out for. One is if I see squared and not squared, and they're both the same, I can really see that as x squared minus something times x. And algebra, our algebra background would say, well, pull an x out. Well, yes, we're going to pull a tangent out. So I'm going to take this tangent of x out, which leaves us with a single tangent of x and just square root of 3. Okay, and by this point we know that with this, having it separated now, that we can set tangent of x equal to 0 and tangent of x minus square root of 3 equal to 0. And our answers will be the arctangent of 0. We would add square root of 3 and get positive square root of 3. So here the arctangent of the square root of 3 equals x as well. So we're going to get two answers, total of 4. So tangent is 0. Tangent is 0 at 0 degrees and 180 degrees. All right. Now tangent is root 3. Tangent is root 3, positive root 3 at 60 degrees and at positive root 3 and at 240 degrees. Thinking that sine would be square root of 3 over 2, cosine would be 1/2. When you divide the 2, it simplifies to just root 3. So here it would be negative root 3 over 2 divided by negative 1/2, and again, equaling root 3. So we have our 4 angle measures. All right, moving on. Looking at the next one. All right. So some of us might want to try and think, oh, divide by 2 or divide by x. The x's are within the sine functions. So, if you're stuck, the least that we can do is get everything to one side. Move everything to one side. So we're going to do that. Sine of 2x. Move the sine over is minus sine of x. Okay. And I know this great identity for the double angle with sine. That's 2 sine of x cosine of x. All right, that's nice, because I can pull a sine of x out, which will give us 2 cosine of x minus 1. Okay, so we have now sine of x equals 0. 2 cosine of x minus 1 equals 0. And that would give cosine of x equals positive 1/2. So sine, the arc sine of 0, says that our x values, our angle measures, are 0, pi, or just 0, and pi, because we're in radians with this problem. Okay, that should be an x, by the way. My bad. So we have 0 pi and 1 pi. And we could also write 2 pi, why not? Okay, so looking at the next one. Cosine of positive 1/2. So cosine positive 1/2, I'm thinking, okay, so I'm positive here. Cosine's also positive in the fourth quadrant. So I'm going to need pi over 3. And in the fourth quadrant, that would be 5 pi over 3. Okay, so speaking to this, if you only gave me 0 and pi and you did not write 2 pi, I'm okay with that, because 0 and 2 pi are the same angle measure in terms of terminal angle. So I'm okay if you left 2 pi out, or if you did not think of it. All right, or if you thought of pi and 2 pi and you didn't think of 0, that's fine. So we have 4 solutions here. So moving on. So approximate. So this keyword approximate tells me that we're going to be using a graphing calculator here. And in doing this, I'm going to get everything to one side. That's the move to make, is put everything to one side. So in doing so, putting everything to one side, that's going to be a little annoying, but we'll be okay, because I wish I didn't say that. So add 3 to this side, add 3 sine of x, and then we're going to subtract 20. Probably wondering, Mr. Beal, why are you doing that? I know. I should be subtracting 15. It's okay, we'll make do with it. So we have 13 sine of x minus 5 equals now 0. All right, now we can isolate sine. So when you isolate sine, you get sine of x equals positive 5 over 13. That is not a fraction that lies on our unit circle. I hope we understand that. I know that. I think we do. This is not a fraction on our unit circle. So when we type this into our calculator, I want to make sure that you are in degree, and we would be hitting, second sine. Okay? So hitting second sine gives us our inverse sine. Placing 5/13 in, it tells us that it's approximately 22.6199 degrees. But as we have seen so far, the angles come in pairs. So we, being a positive fraction, sine is positive. So where is sine positive? Well, quadrant 1, which is our 22.6199, and quadrant 2. So how are we going to get this other angle over here? So I'm going to be using 180 or 360. Let's think. 360 will give me an angle in the fourth quadrant. I don't want that. So I'm going to use 180, and to get in the second quadrant, I have to subtract. So when I subtract 22.6199 from 180, we get our second angle of approximately 157.3801 degrees, and there we have our 2 angle measures. So if I was looking at an angle in the third quadrant, I would have to add the value to 180. So I'll be using 180 or 360. So let me write this real quick for you as a reference. So if I'm in quadrant 2, I'm going to need to take 180 and subtract. If I'm in quadrant 3, 180 plus. If I'm in quadrant 4, we're going to have to do 360 minus. Okay? So let's looking at the extensions, see what we got for this last problem. All right. So it's one of these verify problems that we've done in our extension tasks. Okay. So in this, these can be very time consuming, so I'm going to kind of give you some pointers to start with. So first thing is we want to sketch the graphs. So using our graphing calculator, we want to enter one side of our equation into y1, one side of the equation into y2. Yes, you see zoomed trig here, but if you did not learn this already, when graphing trig functions, we need to have our mode in radian. So if that needs to be something that you change that, okay? So our calculator needs to be in radians. So we graph y1, y2. We are looking to see if the two graphs overlap, if they are identical. If they are identical, then they are identities. If they are identities, then you're going to have to work on getting one side manipulated to appear like the other side. And using our techniques that we have learned, multiplying top by one thing, bottom by one thing, or writing everything in terms of sine and cosine. That might be something we can do here, even here possibly. But we would only do that if the two graphs are identical. If we graph them and we notice that the graphs are not identical, then I need to find one of these values where if I place it into one side, that I get a different, it simplifies to something different on the other side. Okay? So I check test 0, plug it in, plug it in. If I get something different on both sides, that's exactly what I'm looking for. I'm looking for an x value that doesn't make this work. Okay? But if it's an identity, looking at the graphs, I'm not testing it, I'm manipulating it to make one side look like the other. All right, so I'll post in the solutions that I'm attaching to this video, you'll see the worked out solutions here. All right, so best of luck. Again, you're getting closer and closer to preparing for this test, and I will see you in the next video in the next unit, guys.